Good evening and welcome to this webinar on how to AS number properties. My name is Rajat Sudana. I'm one of the co-founders of e-GMAT and I'm going to be a main host today. Supporting me in this webinar is Vipul. Vipul is a subject matter expert at e-GMAT and he is going to be our co-host for the day. Now, in this webinar, we're going to focus on one particular topic, that's divisibility and remainders. And on this particular topic, we're going to go from the easiest to the most challenging question. And to make sure that you're prepared for this topic, we did send 2 video lessons your way. They were on prime numbers 1 and 2. If you've not gone through these video lessons are a part of your free trial. If you log into your e-GMAT account, you get dropped right into the free trial and you can go through them. They're under the number properties module over there. Now, with that, let's talk about a few upcoming free sessions that we have. We have a free webinar on reading comprehension. This webinar is next Saturday, is about 6 days from now on the 4th of July. And then we have a free quant workshop. This workshop is on the 5th of July, which is next Sunday. So the GMAT RC webinar, it's designed for people who are not voracious readers and who need to ace GMAT RC. In this webinar, we look at 3 key reading strategies, and we demonstrate how, if you apply those reading strategies, you can comprehend the most complex passages that the test is going to throw at you, number one, and then you'll be able to answer even the most challenging inference and detailed questions. That's next Saturday, about 6 days from now. And then think of this quant workshop, which is next Sunday, as a proctored mock test, but a mock test that gives you 3 times as many insights. So in this, we not only tell you, what your estimated quant score is, but we also tell you if you're aiming for a Q50 and your estimated score comes out to be a Q45, which are the 3 areas that you need to focus on. What are some of those habits that that are a deterrent to your quant score, so that you get that focused study plan to work on improving your quant. So that's next Sunday on the 5th of July. All right, with that, let's kind of get to know you guys a bit better. We have about 150 students here. I want to know when is it that you guys are plan to take the test. What's your target quant score? And again, you can see the buckets over there, and then what is your current quant score? So where do you think you currently are? All right. All right, let's look at some data over here. Target quant score overwhelmingly upwards of 85% or 85% of the class is aiming for that score of Q50 or Q51, which is just kind of a perfect score. So that's good. We have some people who are aiming for really high scores. With regards to, and then if you add the Q49, that accounts for almost 95% of this group, give or take, or 94%. Depending on when you look at that data. And then with regards to the current quant score, the biggest group here is those who are at a score of lower than 40. And then we also have a good number of you who are in that 43 to 45 and 40 to 42. And we have a few of you who are in that, who are doing better than 48 as well. So that's good. That's good to know. With that, let's go right into the webinar pane, and let me talk about how we will proceed in this webinar. So let's talk about how we'll proceed in this webinar, and let's kind of get to the right slide over there. So the goal of this session, even though we will focus just on divisibility and remainders, the goal of this session is to really tell you when it comes to GMAT quant, it's not about math, but rather it's about logic. And if you focus on logic and if you focus on building a solid process to answer questions, you should be able to answer pretty much any question that the test throws at you. That's kind of what I want to prove over here. And even though my focus is just going to be on remainders as a singular topic in this webinar, what I'm going to prove for remainders is something that's going to remain true for any topic that's related to GMAT quant. So GMAT quant's not about math, rather it's about having some basic foundational math or quant concepts, and then applying a ton of logic. So we're going to focus a lot more on logic than anything else during this webinar. But to be able to apply logic properly, we also need to build a solid process. So the second thing that we're going to focus on in addition to logic is building that solid process. So how will this session progress? We'll start with three very challenging questions. These data sufficiency questions are going to be our holy grail. This is where we want to build up to. Okay. This is what, so you know, this is what you are here for. By the end of this session, you should be able to take it to solve these questions, to get a good crack at these questions, and be confident that you can solve similar questions when thrown if you face them during the test. So this is where we want to get to. So you can see those questions up front. You can attempt those questions up front. But then we're going to start with some very easy questions. We're going to start with some warm-up questions, which are, I'd say, less than 500 level, even though the slide will say 650 level, that they're really, really easy. After those warm-up questions, we are going to go towards some problem-solving questions, simple, then some more challenging problem-solving questions, and then we're going to come back to these data sufficiency questions. So essentially, these questions over here are the same questions that you see over here. And then by the time you go from this problem solving piece, let's just go, you go from here to here, you're going to be able to really solve these questions. Now, how many questions are we going to add in each category? So there are going to be 3 questions. These are going to be our holy grail, and they'll be numbered 8 to 10. Then in warm-up, you'll have about 5 questions over here. We won't even count these questions because they're warm-up questions. Then in easy questions, there'll be 3 questions. Then there'll be another 4, 600, 700 level questions over here that we'll build up to. Okay, and then again we'll come back to these 3 questions again. So you see the question numbers 8 and 10 being discussed over there. So with that, let's get started. Let me actually put in my poll over here. Okay, so actually I have the wrong poll. So I'm going to give you 3 challenging questions first in the beginning of this webinar. Again, these are our holy grail. So let's make sure we get to these questions. Just give me 1 second. So because I don't want to time you guys, what I rather do is I give you this option to really select still solving right now. So I want about 100 people to say still solving. And then when you choose another option other than still solving, I know you're done, and that's when I call time. So that way, this entire group times itself. So can I get 100 people to say still solving before I show the question? I have 77, 83, 85, 90, 91, 94, 97. All right, I have 100 people who've selected still solving. Here is the first question. All right, guys, almost 80% of the class is done. I'm going to give you another 15. 5, 4, 3, 2, and 1. Let me end the poll. I'm going to broadcast the results so you guys can see how you guys polled. Pretty much everyone chose choice C. I mean, that's like the most popular choice. And then we had choice A as well. So I'm not going to discuss this question. As I said, we're just going to solve them. These are our holy grail. Now, here's the poll for the next question. Before I show the next question, I want 100 people to select still solving. All right, let's look at this. 90, 95, 97, 102. Perfect. So here is your next question. All right, guys, 80% of the class is done. I'm going to give you another 15 seconds. Let's get those answers in. 5, 4, 3, 2, and 1. Let me end the poll. I'm going to broadcast the results, and you can really see that C again is the most popular choice, but this time we have the responses a lot more distributed. across each of the 5 choices. So with that, let's go to question number 10. And this is going to be the last question in that holy grail which we want to build up to. Let's select still solving before I show the question. Need 100 people to select still solving. All right, good. I have 100 people over here. And here is the question. Good luck. All right, guys, 80% of the group is done. Let's get those answers in. I'm going to give you another 15 seconds. Five, four, three, two, and one. I'm going to end the poll, broadcast the results. Choice D is something that I'd say the biggest, the most popular one. I mean, 40% of you give or take chose choice D. Choices A and B and C actually were quite popular as well. We've close to 60 odd folks who are in these 3 choices combined. All right, so with that, this is what we're going to build towards. This is where we started with, and this is where we're going to end with. Before I move forward, before we start our building process, I want to understand, how did these questions feel? And again, as I tell people, this is a very low risk environment. This is where you can express yourselves and express your fears, express also your happiness with regards to if you found it easy. You can really say, hey, these were easy. You found them challenging or intimidating, as some of you are saying. You can really say those as well. And these were supposed to look intimidating, although they weren't, but they were supposed to look um, intimidating. All right, and for those of you who say you don't know the right way to solve them, this is what we want to go towards. So, or this is where we want to build to. So that's good. So and the reason why we had these questions up front is because we want to tell you this is where we want to get to. Okay, and this is the motivation that we want to put in plant in your brains, where we say, okay, if you have to get to this, then you have to follow a certain process that we're going to actually now demonstrate over the course of next 15 questions or so. So with that, now we're going to actually change course complete. We're going to start with the simplest of questions that we can throw at you. But the purpose here is going to be not to just solve them, because pretty much all of you will be able to solve those questions. But the purpose over here would be to build a process and to build a process that can be used to solve these challenging questions. Okay. So with that, let's start with some very, very basic questions over here. And because these questions are so basic, what we're going to do is I'm going to not put a whole lot of still solving thing. I'm not going to ask for this. But once we get to 500 level questions, which is after the next set of 5 questions, that's when we're going to do that. Okay. So in the next 5 questions, we're going to have some very, very simple questions that you can do using math. But I don't want you to use math. I want you to build up that habit of using logic. Okay. And again, because these are very basic questions, we will provide you with the solutions, but we won't discuss them. These are concepts that we expect you to know if you're in this webinar. Now, some of you have been asking about answers for prior questions. Again, I'm not going to disclose those answers. Why? Because after going through the basics, I want to give you guys another crack at those questions, so we can see that improvement happen. All right. And again, remember this, it's not about getting questions right here. It's about building that process so that you can get questions right in the test. So with that, let's start with some of the simplest questions that the test can throw at you. Here is your first question. Okay, again, no still solving. You can take a crack at the question right away. All right, about 70% of the class is done. Last 15 seconds, let's get those answers there. Three, 2, and 1. Let me end the poll. I'm going to broadcast the results. You can rarely see choice B is overwhelmingly you've chosen choice B, but 77% of the class has chosen choice B, which is the correct answer. The question over here says Z is a 3-digit number whose digits are consecutive numbers in increasing order. Select the correct statement. And the answer is choice B, that Z is always divisible by 3. Let's kind of see how we get to it. Okay. So what's a divisibility rule for 3? That its sum of the digits should be divisible by 3. So it's a 3-digit number. So we assume the number to be, the digits to be x plus 1, and x plus 2. Why? Because the digits are consecutive numbers in increasing order. So we assume that once we do that, we can really say, hey, sum of the digits is 3x plus 3. You take 3 common, which is 3 times a number. 3 times a number is always divisible by 3, and hence we choose choice B as our correct answer. Okay, so this is something that's there. Now with that, I'm going to clear this poll over here and remove broadcast results, and we're going to go towards our next question over here. Let's take a stab at this one. All right, about 80% of you are done. Last 5 seconds, get those answers in. 5, 4, 3, 2, and 1. Let me end the poll. I'm going to broadcast the results. So over here, what we see is a divide between choice A and choice C, but 94% of you've chosen either choice A or choice C. The correct answer is choice A, and I'm going to say, so in this question, we have to use a process skill, which we call as consider all cases. Okay, so what does the question tell us? The question tells us that Z is a 4-digit number whose digits are consecutive numbers. Okay, so these digits, again, similar to the prior question, are consecutive number, and we have to select the correct statement. You look at the scan, when you scan the answer choices, you really see, hey, we're talking about divisibility by 4. So the first question that we ask ourselves is, hey, what's the rule for divisibility by 4? The rule is that the last 2 digits should be divisible by 4. So we take a few cases. We could say, hey, Z could be odd, which means it could be 2, 3, 4, 5. You can see their consecutive numbers over here. 45, clearly an odd number, is not divisible by 4. Then Z could be even. And in that case, the last 2 digits may be divisible by 4. If for an example is 3, 4, 5, 6, again, you can see consecutive numbers. Or the last 2 digits may not be divisible by 4. Now, an example is again 1, 2, 3, 4, where 34 is not divisible by 4. 56 is divisible by 4. So, there is a possibility that Z may be divisible by 4, which is what makes choice A the correct answer. Now, as you talked about building a process, and when the e-GMAT team did their research, they found out that there are 6 process skills that the GMAT tests, and we've created some example videos on each one of these process skills, and we've applied these process skills on various concepts in number properties, algebra, geometry, and so on and so forth. And these videos are on our YouTube channel. So if you want to click on those and bookmark our YouTube channel, you can really do that. You can click on this process skill and click on browse to, and as you do that, you get to the set of videos, and then you can bookmark the channel over there. Now with that, let me clear all answers, reopen, remove broadcast results, and then let's go to the third warm-up question. Here is the third warm-up question. My apologies. We didn't have a poll with 4 options, so I now shared a poll with 4 options. If you can please select the choices again, that'd be great. All right, about 80% of the class is done. And I'm going to create another 5 to 7 seconds over here. 3, 2, and 1. Let me end the poll. Let me broadcast the results. You guys did really well. 82% of the class got it right. The correct answer is choice C. And the way to go about doing this is to really say, hey, the divisibility rule for 8 is that the last 3 digits should be divisible by 8. Hence, we look at this and say, okay, 897, we divide that by 8. It gives a remainder 1, which means that what we should do to get the closest number is subtract 1. And as we subtract 1, we get the number ending with 896, which is choice C. How many of you, and I want to just ask this is kind of where we start getting into the process skills over here. How many of you approached it this way rather than, or rather, how many of you approached it this way? And if you did not approach us this way, then you probably divided each one of these numbers and figured out which one of these is divisible. And that's the wrong way of doing it. You'd still get to the answer, you'll still get the correct answer, but that's not what we call as a scalable way that will allow you to answer questions. Okay. The way to do it is to really focus on the last 3 digits, see, okay, that the remainder is 1, which means that if you subtract 1 from it, and 1 is the smallest remainder one that you can get other than 0. If you have a positive remainder, then 1's the smallest remainder. If you use the options to do it, that's a non-scalable way of doing this. It's not a way that we recommend that you use. Okay, the way that we recommend is to do this. Why? Because this is a scalable way of doing it. I can really have, instead of having an 8-digit number, I can essentially have a 10 or a 15-digit number and still use this option over here. So, all right. So with that, let's go forward. I'm going to clear all answers, remove broadcast results. We're going to get to the next question. Over here, here's question number 4. All right, about 80% of the class is done. Let's get those answers in. 3, 2, and 1. Let me end the poll. I'm going to broadcast the results over here. So you can see 72% of the class got it right. The answer is choice D, which is 3. Uh, but in this case, I want to make sure that we get it through the right process, not by back solving, but rather by using what we call as the Euclidean remainder equation. So what's the Euclidean equation? It is that dividend is equal to divisor times quotient plus remainder. So that's an equation we're going to use throughout this webinar. And if you understand this equation, if you know how to apply this equation, you'd be able to answer every question that the test will throw at you. Even the data sufficiency questions that we saw up front, each one of them can be answered very easily just by applying this equation. So let me just repeat this. So dividend, and what is dividend over here? Dividend is n, okay, is equal to divisor. What's divisor? Divisor in this case, what was given to you is 204, okay, times quotient. We don't know what the quotient is. And then what's remainder? Remainder is the number 3 over here. Also, the remainder is something that we need to find when we change the divisor from 204 to 4, as is asked by us in the question. Okay, so we say, okay, what we have to do is we have to express n as 4p plus r. Okay, why? Because our divisor now changes to 4 rather than 204. Now what's given to us? And remember, the remainder always has to be less than the divisor. That's why you have the remainder, right? And a remainder always has to be greater than or equal to 0. All right. So what's given to us is, we are given to us that n leaves a remainder 3 when divided by 204. So we've translated that English into an equation. That's another process skill called translate. And again, this is a simple use of translate, but we have more sophisticated use of translate in this set of process skill links. So what we are given is n is 204q plus 3. Why? Because it leaves a remainder 3 when divided by 204. So where q represents the quotient over here. And what we have to do is we have to express n in this form. Okay, so we combine this and we really say, hey, let's write 204q in terms of 4p. And how do we go about doing that? We say, hey, 204q is 4 times 51q, and which means p becomes your 51q. So we can write n as 4 times 51q plus 3. This first term, 4 times something, is always divisible by 4. So you get the remainder as 3. Okay, this is the Euclidean method. This is something that we're going to follow again and again. You might really say, hey, this seems to be a bit more complex than by my number substitution or back solving method. But you're going to really see, as questions become more challenging, this really becomes this method really becomes a savior, and which is what you want to get to. No one's in this class to be able to solve these questions correctly. You're here in this class because you want to be able to solve those data sufficiency questions correctly. Okay. And this is the fundamental concept in remainders anyway. So with that, let's go to our last warm-up question for the day. And here is the last warm-up. About 70% of the class is done. 20 more seconds. 5, 4, 3, 2, and 1. Get those answers in. I'm going to end the poll. I'm going to broadcast the results. So in this question, we're going to use the same Euclidean equation and solve this particular question. Again, warm-up question, easy question over here. What's the equation? That dividend is equal to divisor times quotient plus remainder. You may want to just write this down because I'm going to reference this equation in every question that we solve from now on. What do we have to do? We have to find the remainder when n is divided by 5. So we have to express n as 5p plus r. But remember, when remainder is equal to or greater than 0 and less than 5. Remember, the remainder always has to be less than the divisor, where the divisor in this case is 5. Okay. What are we given? We are given n is 205 q plus 6. Why? Because it leaves a remainder 6 when divided by 205. So we use our skill of visualization and we really say, okay, let's express 205q as in terms of 5p. So we really write down 205q as 5 times 41q. Okay, and then you might really think that the remainder is 6. But remember, our constraint is that, and that's another process skill that we call as applying constraint. So the remainder has to be less than 5. So we combine these two things and we express 6 as 5 times 1 plus 1. Again, 5 times 1 is divisible by 5. So the remainder that's left is 1, which is choice A. Okay, and then that's how we want to go about solving these questions. Now, these are easy questions, but from here on, we're going to make the question slightly more difficult, then even more difficult, and then even more difficult, and then we're going to go towards data sufficiency. Okay. Now, what can you get from the 5 questions that you solved so far? You should have gotten all of these questions right. And if you didn't get all of them right, then I think it's really important that you revise certain concepts. Why? Because when it comes to real GMAT questions, and they weren't real GMAT questions, these were easy questions. This is not why you are here. The extent of application becomes even more advanced. So you need to have that clarity of understanding. Okay, but so far hopefully we're starting to have fun now, because if you're starting to have fun, we'll have even more fun going forward. Now, one thing that I want to really say is that as we move forward, I want to see more participation. I have 200 plus students in this webinar, and I see about 150 of you, give or take, responding. Now, you are here. The best way to get feedback that helps you, improve is by participating. Again, this is a low risk environment. No one's judging you here. You are here to improve, and the way to improve is to participate. Okay, because then you'd be able to really see that how and why you're faltering. Now we're going to go towards real GMAT-like questions. I'm going to use this process where I'm going to use still solving over here. So I want about 100 of you to say still solving, and that's something that we're going to repeat again and again. And that way, when 80% of you choose another option other than still solving, I know that you guys are done, and that's how I would call time. So that way we're not rushing through it, uh, and at the same time we are doing justice to 80% of the group over here, and that's kind of my purpose. And in a webinar where we have 200 plus students, it becomes really difficult to do justice to everyone. It's my apologies for that, but again, our goal is to do justice to 80% of you, and that's one of those things with free webinars. People come with different levels of preparation. All right, guys, I have 91 people who've selected still solving. I need another 9 folks before I show the next question. Can I get 9 more people to say still solving? Thank you. Appreciate that. Here is your next question. All right, guys, 80% of you are done. So let's get those responses in. Last 5 seconds. 5, 4, 3, 2, and 1. So before I broadcast the results, I'm going to ask you this question. How many of you, and it's a yes no poll, you can see it right below the question poll. How many of you did the actual math to solve this question? Select yes if you did the actual math. Select no if you used the Euclidean equation to solve this question. Okay, I want to really see the responses. So about 60% of you did the actual math, and about 40% of you used the Euclidean equation. I want to traverse this number over the course of next 3 questions, at least reverse this number as we proceed forward, because we want to use the Euclidean equation more and more. So here's how we go about doing this. It's exactly the same process that we did in the prior question. What we're going to use is we're going to use this equation where we said dividend is divisor times quotient plus remainder. And so essentially we ask ourselves, what do we need? We need to find the remainder when m is divided by 15. So my divisor is 15. So I have to express m as 15p plus r, where the remainder has to be less than the divisors, which is 15 in this case. What's given to me? M is 30 times 8.2. Again, it's not in the form that I like. I like this form over here. So let's express it in this form. Okay. So when m is divided by 30, we get the remainder as 8.2. So I say m is equal to 30 times 8 plus 30 times 0.2. Why? Because I expressed 8 as 8 plus 0.2. So then that's kind of what we call as the process skill of visualization. You're going to really see how we expand on the skill as we make questions more and more challenging. So visualize this and say, hey, this is what we are given. Then this is what we want to get to. So let's kind of map them because they look kind of very mappable to me. So I express 30 times 8 as 15 times 2. So 30 as 15 times 2, which is what we've done over here. And then you can see times 8 over here. So I see that this first term is always divisible by 15. And then 30 times 0.2 is 6 over here. So I'll do that. And then I get remainder as 6. Why? Because my first term, this term over here, leaves a remainder of 0 when divided by 15. So that's how I go about using the Euclidean equation. Now we want to try, the next question that you're going to see is going to be very, very similar. Try following this process. Try to apply the constraint, and let's see if you guys can get the correct answer and get it quickly. Okay, so let's get to 100 people saying still solving. But 70% of you got it right. So my apologies, I didn't publish the results. But 70% of you got it right. So the correct answer is 6, which is choice C. All right, I got 100 people saying still solving. Now I'm going to show the next question. Very similar question. Try applying the process. All right, guys, 80% of you are done. Let's get those responses in. 3, 2, and 1. Let me end the poll and broadcast the results. And you can really see those of you who responded to this one, pretty much everyone's chosen choice C, which is the correct answer. Again, same thing, we really say, hey, dividend is divisor times quotient plus remainder, where remainder has to be less than 30. That's why, because our divisor is 30 over here. What's given to us, right now we've reversed the divisors over here, and what's given to us is m is 15 times 8.2. Let's express it in a Euclidean form. And so we divide 8.2 as 8 plus 0.2. We visualize and say, hey, we want to express m as 30 times something. So we look at this part and we really say, hey, 15 times 2 times 4. And then 15 times 0.2, we do the math over here. That's the only place we do the math, and we get 3 over here. And then we really say this is really 30 times 4 plus 3. Thus, our remainder is 3. Okay. Hopefully, more of you use the Euclidean equation. The next question, again, very similar. We're going to use the Euclidean equation to do that. So let's get to still solving. That way, we'll get through the first set of questions. These are 500 level questions, or 500 to 550 level questions, and then we're going to move to more challenging questions. And so phase 2, phase 3, and then we'll finally get to the data sufficiency questions and try and solve them. All right, 100 people saying still solving, guys. Let's go fast. We have a lot of ground to cover in this webinar still. 100 people saying still solving. 5, 4, 3, 2, and 1. Let me end the poll. Here is your next question. All right, guys, 80% of you are done. Let's get those answers in. 3, 2, and 1. Let me end the poll. gonna, oops. Guys, can you put those answers in somehow? The system cleared the poll once again. I'm gonna give you another 5 seconds to put those answers in. 3, 2, and 1. Let's put those answers in. Here are the answers. Overwhelmingly, you guys got it right. 18 is the correct answer. So let's kind of see. It's again the same process. We really say, hey, dividend is divisor times quotient plus remainder. And what we are given is that m by 15 is 9.2, which means we can express m as 15 times 9.2. Now, what do we have to find? We have to figure out what's the remainder when m is divided by 30. So which means we have to express m as 30p plus r. Again, this is purely us using the Euclidean equation. And again, what's the constraint? The remainder has to be less than 30. So how do we go about doing this? We say, okay, this is what we are given over here. So let's kind of first try and express it in the right form. We visualize this and say, hey, okay, m is 15 times 9 plus 15 times 0.2. Okay, now, but we want to express m as 30 times something because that's when we get the remainder. So we really divide 9 as 8 plus 1. Okay, and you can really see we saw 15 times 0.2 as 3, which is what we got over here. So we split 9 as 8 plus 1. Why do we split 9 as 8 plus 1? We'll really see that. Because when you do that, you do the distributive property of addition. You can really say it's 15 times 8 plus 15 times 1 over here. Okay, where did we get 3 from? This 3 is from when you multiply 15 times 0.2, you get 3. Okay, so, and you can see this 3 is maintained over here. Now, as we even move forward, we really say, okay, it's 15 times 2 times 4. We expressed 8 as 2 times 4. Why? Because we want to express it in this form, 30 times something, 30 times p. That's our goal. And you do that, you really get 30 times 4 plus 15 times 1, which is over here. This is where you bring this down. And then you bring the 3 down over here. You see that this is in this form, m is equal to 30p plus r, which means what is our r? 15 plus 3, which is 18, which is where you get choice E as your answer. Now, I want to ask you, so far I've tried to go at a reasonable pace. I want to understand, do you want me to slow down? Do you feel the pace is just right? Do you want me to just pace up, go faster? Let's get about 100 responses before I broadcast the results so that we don't bias the responses. Again, because I've been getting conflicting feedback in the Q&A pod. And so 3, 2, and 1. I have 120 responses over here, give or take. Let me end the poll. And you can really see, but the biggest group over here feels the pace is just right. There's a reasonable number of you who want me to pace up. Very few of you want to pace down. Again, my apologies, guys. Our goal is to cater to everybody over here, but when we have these many people, it becomes slightly difficult to cater to everyone. So again, my apologies in advance with this. Okay, so we started with the Euclidean equation. We applied the Euclidean equation, and we increased the complexity of problems as we went from question number 1 to question number 3. Okay, the key skill that we used was visualization. The first question, we basically were given m as 30 times 8.2, and we had to figure out the remainder when m was divided by 15. The second question, it was just the opposite. We were given m as 15 times 8.2. We had to figure out the remainder when m was divided by 30. And in the last question, we were given m is 15 times 9.2, not 8.2. And then we had to use the distributive property of addition to figure out the remainder when m is divided by 30 again. Again, it's the same skill of visualization. The questions became progressively more difficult. Now we're going to go and we're going to solve slightly more challenging questions as well. Okay. For the first question, the answer was 6. So I think whichever choice it was 6. And we'll get the PDF to you. So we're going to talk about applying this concept, okay, and in more sophisticated manner. But I want you to be 200% comfortable with applying this equation in general while solving questions. I want this equation for you to become second nature over here. All right. Because why? Because we're going to build upon our understanding of this particular concept. So we are now going to talk about what's called adding and multiplying remainders. So let's look at this over here, and I want you to now pay a lot more attention, because it's a bit more intense than what we've been doing. So let's say if I were to ask you, what is the remainder when 31 plus 43 is divided by 7? And the answer over here is 4. Now let's understand how can we go about solving this. There are two ways to do this. One is you could really go about doing this where you say, okay, I'm going to add these two numbers. So I'm going to say 31 plus 43 is 74. And then I find the remainder of that. So 74 divided by 7, and I get the answer as 4. The other option is I kind of divide each one of these numbers by 7 and then get their individual remainder. So the remainder of 31 when divided by 7 is 3. The remainder of 43 when divided by 7 is 1. And then I add these two remainders and I apply my constraint that the remainder has to be less than 7. Why? Because the remainder always has to be lower than the divisor. And either of these options seems good enough. Why? Because 31 plus 43 isn't as bad. So either of these options is good enough. Now, what if we had to multiply these numbers? Okay. What if the question were, what is the remainder when you multiply 31 and 43 and then divide them by 7? And the answer to that, if you were to quickly do this, is 3. Now, how do we go about doing this? There are two ways of doing it. One is you multiply the two numbers. So you multiply 31 times 43 and you get 1333. You divide that by 7. When you do the math, you get the answer as 3. And the math seems long, it's difficult to do this. Okay. The other sequence is you do 31 divided by 7 and you say, I'm going to get the remainder as 3. And then you divide each of these numbers individually. So you do 31 by 7, you do 43 by 7, you get the remainder as 1. You multiply these two remainders and you get the answer as 3. Now clearly over here, option 2 or sequence 2 seems a lot more efficient. Why? Because doing this math seems more problematic over here. It's clearly longer. So option 2 is a lot more efficient. Okay. So the concept over here is when you have a product of two numbers and you have to find the remainder of a product of two numbers, then you can just divide or find the remainder of the individual numbers and multiply them. As long as the product over here is less than your divisor, you are fine. Okay. So that's really important. Let's see why does this work, and that's kind of where the Euclidean equation comes back in again. Okay. Again, this works because of this equation, and we're going to really apply this equation to tell you why this works. Remember, same two numbers, 31 plus 43 divided by 7, and we really said you can add the two remainders over here. Let's see why this works. We can express 31 as 7 times 4 plus 3. You guys clear so far? You can express 31 as 7 times 4 plus 3. Okay. Why do we choose 7 over here? Because 7 is our divisor. Remember, this is the Euclidean equation, divisor times quotient plus remainder, which is exactly what we're doing over here. Then we can express, hold on, 43 as 7 times 6 plus 1. So when you do 31 plus 43, what you're essentially doing is you're doing 7 times 4 plus 3, which is 31, and you're doing 7 times 6 plus 1, and then you add that. Okay, so we just reshuffle the numbers and we say 7 times 6 plus 4, and then we add our remainders over here. Then we ask ourselves, hey, is the remainder less than the divisor? If the answer is yes, then 4 becomes a remainder. Now, can you see how using the Euclidean equation, we arrive at this property that the remainder of a sum is the sum of remainders? Is that clear? Let me put the poll up, yes and no. All right. Now let's see how can we extend this to the product. Okay. So again, remember, what did we say earlier? When you want to multiply, when you want to find the remainder of a product of two numbers, which is 31 times 43 in this case, you can find the remainder of individual numbers, and then you can multiply the two remainders to get the remainder of the product. Okay. So let's see why this works. Again, we're going to use the Euclidean equation over here. So we express 31 as 7 times 4 plus 3, and we express 43 as 7 times 6 plus 1. Again, I'm going to take this poll again, and for those of you who say no, you can put the question in the Q&A pod. So let's see what happens when we multiply 31 and 43. We say 31 times 43 is 7 times 4 plus 3 multiplied by, here is where you can see the multiply, 7 times 6 plus 1. Again, we use the distributive property of multiplication, and we rarely get all of this. So I'm going to pause over here so you can really see how we got this equation. It's essentially multiplying, just opening the brackets and multiplying. So you get 7 times 4 times 7 times 6, which is term 1 over here multiplied by term 1 over here. Then you take 3, you multiply it by 3 multiplied by 7 times 6. Then you take 1 over here and you multiply this by 7.4, which is how you get this term over here. And then you multiply the last two terms. Okay, so this is simply how do you open a bracket and multiply the terms over here. And what you see when you do this is there are a bunch of terms. This is divisible by 7, this is divisible by 7, this is divisible by 7, which means they leave a remainder of 0. The only term that's not divisible by 7 is this one over here. Okay, so we can write all of this as 7 times something plus this, our Euclidean form, and which is 7p plus 3, which means your remainder is 3. And what is 3? Is the product of remainders. All right, so everything's clear so far? That's good. So this is what we call as the additive and multiplicative property of remainders. We're going to use this property to solve a few questions. Let's get to still solving. 100 people saying still solving. Five, 4, 3. Guys, 100 people saying still solving. 93, 95, 97, 99. All right. Here is our next question. All right, get those answers in, guys. Most of you are done. 5, 4, 3, 2, and 1. This is what I'm going to demonstrate over here is a classic case of when people learn new things, they forget the basics, and they forget the basics, they make mistakes that they usually don't make. So let me end this poll over here. You can see that we have 42% of you who've chosen choice C, which shouldn't have happened. Choice C is not the correct answer. So let's kind of look at this over here and see what's given to you. Hold on. Let's see what's given to you. What's given to you is, and I'm going to clear these answers. What's the remainder when 24 to the power 3 multiplied by 38 to the power 3 is divided by 3? And the answer directly should have been 0. Why? 24 is divisible by 3. Just because you learned all of those fancy things about multiplicative property doesn't mean you apply it using a hammer, right? Okay, so the remainder has to be 0. The key thing which is there is you've got to feel the question when you see it. Just those basics piece, just don't forget this just because you've learned something new. Okay, 24 is divisible by 0, so 24 multiplied by anything will 24 is divisible by 3. I'm sorry, nothing's divisible by 0. That rule of divisibility by 0 doesn't exist. So 24 is completely divisible by 3, which means, hey, the remainder is 0, and you multiply anything with 24, and it's always going to be divisible by 3. Okay, so again, just make sure you apply a conceptual understanding. Now, even if you did the product rule, you would have gotten to this 0 times 1, which is what Mradul is saying. That's correct. Or sorry, 0 times 2, and that would have been you would have gotten 0 as well. So that's good. I'm good that you're applying this and getting to the correct answer. All right. So in the next one, we're going to apply the multiplicative property. So let me clear all answers. Let's get to still solving. And we're going to pace it up right now slightly. Let's get about 80 people to say still solving, because I see you guys are getting tired. 80 people to say still solving. 82, good. Here is our next question over here. So let's apply what we learned over here, guys. Okay, 80% of you are done. That is good. You're getting much better at this. That's great. 3, 2, and 1. Let me end the poll. Broadcast the results. Oh, damn it. Can you please select the results again? I don't know why this happens. But overall, I'm gonna good. Pretty much everyone's chosen. Broadcast the results. But 74% of you've chosen choice C. It is the correct answer. You guys are getting really good at it. So how can we go about doing this? Let's write this expression as what we're given is 25 into 38 to the power 3. What's the remainder when it's divided by 3? So let's write this expression as this multiplied by this multiplied by this. So it's a product of two numbers multiplied with itself 3 times. So what we do is we call this, let's call this 1. Let's call this term over here 2. 2, and it should appear over here 3. So each of these terms 1, 2, and 3, we can find the remainder, and then we can multiply the remainders for each of these terms. So let's do that. Let's find the remainder of 25 times 38. So we apply our multiplicative property. We say the remainder of the product is the product of individual remainders, which is what we do over here. So 25 by 3, my remainder is 1. 38 by 3, my remainder is 2. Okay, so and because we have these terms 3 times over here, so we cube this entire thing. So 1 times 2 to the power 3, we get 2 to the power 3, which is 8. But remember, the constraint is the remainder has to be less than 3. So we do 8 divided by 3, or we express 8 as 3 times 2 plus 2, and we get the correct answer as 2, which is choice C. All right. Okay. What just happened? So, how are we feeling right now? Are we getting the hang of this Euclidean equation? Are we getting the hang of this? Let me clear all answers. Better. Okay, good. That's good. So what we learned is that calculations can be simplified when we start using the Euclidean equation, and we've seen how we do this for additive and multiplicative properties. Okay, and this is something which is great. Now let's kind of look at another concept. What's the concept? The concept of negative remainders. It's an extension of positive remainders, and the reason why we are studying negative remainders is because sometimes it's a lot easier to express numbers in not as sum of two numbers, but as a difference of two numbers overall. Uh, so again, the Euclidean equation remains the same. We still apply the same equation. And what's the constraint over here? That remainder has to be less than the divisor, and remainder has to be greater than or equal to 0. So that's my constraint. So let's see if we want to figure out the remainder of 5 divided by 2. So one way of doing it is we express 5 as 2 times 2 plus 1. Another way of doing it, and the same thing, let's kind of say we want to figure out the remainder of 8 divided by 3. We can really say, hey, 8 is 3 times 2 plus 2 over here, and we get the remainder as 2 and the remainder as 1. But there's another way of doing this as well. What if we write this down as 5 as 2 times 3 minus 1, so 6 minus 1, and we write 8 as 9 minus 1. Sometimes that's a better way of doing it. Okay. So in that case, we can really see that the remainders that we get are negative remainders. If we compare this form over here to my Euclidean form, okay, that the remainder is a negative remainder, and which is something that can't happen. Why? Because the constraint is that the remainder has to be greater than or equal to 0. So let's see how we can express a negative remainder into a positive remainder. Okay, so what we really say, we apply constraints, and let's kind of figure out how we convert this to a positive remainder overall. Okay, so how do we go about doing this? We actually add the divisor back to our remainder. So we really say, hey, 5 is 2 times 3 minus 1. Remember, this is the same thing over here. And then what we have done is we've added the divisor and subtracted the divisor. So the divisor in this case is 2 over here. So we've added 2 and subtracted 2, which in a sense means that we've actually added 0. We rearrange the terms, and as we rearrange the terms, what we really see is 2 times 3 minus 1. That's you know, divisor times quotient form over here, this part over here, or if I do this on top just for neatness. So 2 times 3 minus 1 is really in this form, and my remainder is this form over here, minus 1 plus 2. So what's my remainder? Minus 1 plus 2 is plus 1, and I get the remainder as 1. So sometimes this becomes easier to express. Okay, let's do the same thing with this part over here, where we are expressing 8 as 3 times 3 minus 1. What are we going to add and subtract? We're going to add and subtract the divisor, which is 3. Okay, so we really say plus 3 and minus 3. And as we rearrange the terms, we can really get it into the form where we say 3 times 3 minus 1 and then minus 1 plus 3. So what is our remainder? Our remainder really is the sum of minus 1 plus 3. So what is our negative remainder? Or what is our positive remainder? When we get a negative remainder, we add the divisor back to that negative remainder to get our positive remainder. So that's the concept of negative remainders. And let's see how we apply this particular concept on certain questions. So I'm going to reopen the poll. Let's select still solving. Let's get 80 people to select still solving before I show the next question. All right, 77, we are almost there, 78. And again, if this concept is slightly fuzzy, it will become really easy over there. But the concept is, what's your positive remainder, or the actual answer is negative remainder plus divisor. So let's first find step 1, find the negative remainder. Step 2, add the divisor to it. Here is your first question. Try solving this using negative remainder. All right, 80% of you are done. So let's get those answers in. 3, 2, and 1. Let me end the poll. And I hope I don't mess it up right now. Let me broadcast the results. Cool. You guys got it right. How many of you, and I'm going to put in my yes, no poll here. Hopefully I can find that. Let's get this. How many of you use the concept of negative remainders to solve this? I know, because you can solve this using positive remainders as well. If you use the concept of negative remainders, select yes, otherwise select no. And again, if you didn't use it in this question, you're going to definitely use it in the next one. So don't worry about it. All right, so let's see how we go about doing this. Okay, what we have asked is, what's the remainder when the sum of these two numbers is divided by 3? And these numbers seem very, very complex, but we know they're not, because we have the tools to solve them now. So we say the remainder of a sum is a sum of individual remainders. And what we clearly know is that the first term, which is this term over here, has a remainder of 0. Why? Because 24 by 3 gives us a remainder of 0. So what we need to focus on is the remainder that this term gives us. Okay, so then let's focus on the remainder that this term gives us. So one way to do it is to really say expressing 17 as 3 times 6 minus 1. Or we can express 17 as 3 times 5 plus 2. If we express 17 as 3 times, so it's clearly that, processing with minus 1 is much better than processing with plus 2. Why? Because we have a power of 7 over there. So we get to this and we say the remainder is minus 1 to the power 7, which is minus 1. But this is a negative remainder. We've got to get a positive remainder. So what do? We add 3 to it and we get a positive remainder as plus 2. Okay. That's easy processing. If you chose the positive remainder route, what you would have gotten is, hold on, if you chose the positive remainder route, you would have gotten 2 to the power 7. That's 128. You divided 128 by 3, you would have still gotten the answer as 2. But it's a bit more math over here. Okay. But hopefully you guys have now understood how to use the concept of negative remainders. Why? Because in the next question, so how do you solve with a positive remainder? Okay, let's just do this. Let me just bring in a notepad over here. So with a positive remainder, the way you would do it, and I don't have that over on the slide, is you would have gotten the remainder as 2, and let me get my ampersand over here. 2 to the power 7. Man, I'm having difficulty navigating the keyboard. Yes, shift and 6. You would have gotten 2 to the power 7 divided by 3, which would have been 128 divided by 3, which, by the way, would have been 2. Again, 128 by 3 is 128 is 3 times, I believe, 42 plus 2, which means that the remainder is 2, sorry. Okay, that's how you do with positive remainders. But again, that's not how you would want to go about doing it. Now, next question, still solving. 80 people. Let's do that. I have 33 people saying still solving. 51, 64, 73, 79. One more. Hey, great. 88. Here's the next question. All right, 80% of you are done. Let's get those answers in. 3, 2, and 1. Let me end the poll. Broadcast the results. Man, you guys are killing it now. So what do we have to do? Again, same thing. Find the remainder. The divisor, the dividend remains the same. The divisor now has been changed from 3 to 6. It's become slightly more sophisticated. Again, we really say, hey, the first term over here, the remainder is 0. Why? Because 24 is completely divisible by 6. The second term over here is what's going to leave the remainder, 17 to the power 7 divided by 6. So we say we can use, hey, express 17 as 6 times 3 minus 1 or 6 times 2 plus 5. Now clearly 5 to the power 7 is difficult math. I don't want to do that. I'm going to use this path. Why? Because minus 1 to the power 7 is very, very nice. So I get to this and say, hey, minus 1 to the power 7 is minus 1, but again, I can't have a negative remainder. What do? I add back my divisor and I get the remainder as 5. So minus 1 plus 6 is 5. Option E is the correct answer. Pretty much everyone who answered got it right. So how are we feeling now? So if you can do this and if you can do the positive remainder, then you should be able to do our next data sufficiency question very easily. So how are we feeling so far? Confident. Is negative remainders fun? Or is the Euclidean equation fun? Remember this. This is just over the course of an hour. So we started with the sum and product of remainders at 8 a.m. my time. It's 8:41 a.m. my time over here. Okay, Vivek has a question. What if the power over here instead of 7 were 6? What if the power were 6? In that case, minus 1 to the power 6 would have been plus 1, and then your remainder is already positive. That plus 1 would have been the answer in that case. Okay. So that is where, what in case if the power were an even power, then in that case, you would get minus 1 to the power 6, which is plus 1, and that's your remainder, then plus 1. The answer would have been 1 plus 1. Remember, the constraint still remains. The remainder has to be less than the divisor. You won't add 6 to it in that case. So the question really is, I think, why don't we do this? I'm going to put in a poll question here. Instead of the power 7, what if, let's just put in a poll question because you guys have this piece over here. And because you guys have this doubt, I'm going to put in this poll question. Let's just see this. Why can't I delete this? What is the of 17 to the power 6? What is the remainder when 17 to the power 6 to the power 6 is divided by 6? Now, okay, the options are 0, 1, 2, 3, 4. No, let's call it 5. Okay, so let me bring in my poll question here. What's the remainder when that happens? And again, A, B, C, D, E. Very quickly. What's the remainder? This 3, 2, and 1. Let's get those answers in quickly, guys. 3, 2, and 1 again. have 100 responses so far, give or take. Let me broadcast results. Choice B is the correct answer. 68% of you got it right. So let's see how we'll go about doing this. I'm going to remove the options over here so that I get some more real estate space. Okay. So what I do is I express 17 is equal to 18 minus 1, which is equal to 3 times 6 minus 1. Okay. And remember, when I do that, why do I have, hold on guys, 3 times 6 minus 1. And when I do that, my dividend becomes, and I'm going to copy this. And guys, I'm doing this real time, so have some patience with me. My dividend becomes 3 times 6 minus 1 to the power 6. Okay. So which means I get minus 1 to the power 6. What is minus 1 to the power 6? What is minus 1 to the power 6? Plus 1. Yes, it's plus 1. Now there is no negative remainder. And that plus 1 is less than 6. So my remainder is equal to 6. I don't need to add my divisor, or the remainder is equal to 1. Okay. So that's basically why we don't need to add the divisor back, because my remainder is already positive. Remember, you add back the divisor only when you have the remainder as negative. When we had the power as 7 over here, when we had the power as 7, you had this to the power 7, which means you had minus 1 to the power 7 over here, which means your remainder was minus 1, which means that it's a negative remainder, which means that you had to then add 6. So minus 1 plus 6, and that gave you 5. All right. You can't have a negative remainder, but if you, by applying the concept, you get a positive remainder, don't need to add the divisor back. All right. So hopefully that gives you the answer to this. So now we're going to go back to our data sufficiency questions. Why? Because we now have the tools to solve them. Okay. So we're going to go towards question number 8. Remember, this is how you guys solved it last time. Now we're going to solve the data sufficiency question once again. These are 750 level questions now. You're really getting there. But again, you have all the tools now. So still solving. I need 80 people to say still solving. 74, 79, 80. Good. Here is our question. Good luck, guys. 80% of you are done, guys. Let's get those things in. Let's get those responses in right away. 3, 2, and 1. Let me end the poll, broadcast the results. And this is great. I mean, choice A is the correct answer. Last time, only 29% of the class did this. Now, 53% of the class chose choice A. Now, when we started this, we now have about 165 students here in the class. When we started, we had 210. So even from a pure number standpoint, you can see more of you've gotten this correct. That's great. Let's see how we get to this. So what we're told is, what's the remainder when positive integer p is divided by positive integer m, where m is greater than 1? Excuse me. So what do we have to find? We have to find the remainder. All right. So we have to express p in terms of m. All right. We're not given a whole lot about p and m other than the fact that both of them are positive and m is greater than 1. So let's look at statement 1. What does statement 1 say? Statement 1 says that p is equal to m plus 1 to the power 8. Let's kind of divide p by m. So when we do p by m, we really get this. We say m plus 1 to the power 8 divided by m, and we have to find just the remainder of this, which means that we can find the remainder of each of these terms. So m plus 1 divided by m to the power 8, which means that the remainder is going to be 1 to the power 8. Why? Because each of these terms is going to leave a remainder 1, which means the remainder is 1. We can get a definitive answer, and hence we say, hey, at least statement 1 is sufficient. Again, this is exactly the same thing that we done over here with positive remainders. How many of you were able to get to this part properly? How many of you were able to get to this part properly? 85% of you were able to get this one. So how do I divide on the right side by m? Remember, we really said 24 or 25 to the power 7 divided by 3 means that you can divide 25 by 3, get the remainder, and then raise that to the power 7. No, Chris, we don't need to multiply this side by 7. Okay, let's see, why not see? Let's kind of go over here. Okay, so 78% of you were able to do this. So let's kind of look at a very, very basic question. Let's do this. Let me get my notes pane over here. So if I say 24 is equal to 3 times 8, and let me just very, very simple. It's how just you figure out relationships in math. Everyone's clear? 24 is 3 times 8? Yes, no? Right? 24 is 3 times 8? Perfect. Now, if I were to really say, what is 24 by 6? 24 divided by 6, the answer is 4, right? The answer over here is 4. And which is also the same as 3 times 8 divided by 6, where also the answer is 4. Okay. So when you divide the left side, if you say left side is equal to right side, if you divide the left side by a particular number, in this case you've divided the left side by 6, you're also going to divide the right side by 6 to maintain that equality. That's just how math works. Okay. What if the power was 7? Hugo, in this case, even if the power were 7, it would remain the same. Remember, it's a positive remainder here, not a negative remainder. Okay. Let's now look at option statement 2. Statement 2 really tells us what's the value of m. Does it tell me anything about p? Does statement 2 tell me anything about p? Yes, no, let's just go over here. Does statement 2 tell me anything about p? No, p could be anything. Okay, which means statement 2 clearly is not sufficient. Statement 1 is sufficient, statement 2 is not sufficient, which means that I remove options D as well as options. Uh, so I remove option D as well as option B over here. Okay. So for those of you who are really saying, how did m plus 1 to the power 8 lead to 1 to the power 8 and the remainder 7? Raghav, isn't this exactly, let me just move over here. Adding and multiplying remainders. You remember, how many of you remember this equation, this question? How many of you remember this question? All of you remember this question. All right, let's kind of, I'm going to end this poll. Let's assume this expression over here is P. The 3 is the same as M. So in this case, we did exactly this. We said, hey, 20, you have to figure out the remainder of 25 multiplied by 38 divided by 3. So what we can do is we can find the remainder of each term, which is 25 times 38, 25 times 38, 25 times 38. Okay. And then we can multiply the remainders. That's the multiplicative property, right? So we found the remainder of each term. We raised it to this power over here. Or let me just get this. I'm going to use my timer pod. What is the remainder of, I want you guys to tell me, 16 to the power 7 divided by 3. So 16 to the power 7 is a single number. Let's get that in short answer pod. And tell me also, how did you go about doing this? Let's get the answer in the short answer pod and tell me how you went about doing this. How did you express 16 as? You express 16 as 15 plus 1 and you got 1 to the power 7. Okay. Let's now tell me the remainder of 4 to the power 7 divided by 3. 4 to the power 7 divided by 3. Right? 4 to the power 7 divided by 3 is also 1. 1 to the power of 7 is 1. Isn't this the same form where I'm saying P is m plus 1, 1 to the power 7? When I say 4 by 3, isn't it m plus 1 to the power 7 divided by m, where m is equal to 3, right? That's how we got it, for those of you who are still confused. You guys have done this in numbers. You just have to visualize this. This is the the process skill of visualization that you're not getting. But we can really see how from 29% we got to 54% over there. Okay. Now with this, we're going to now solve the last question for the day. I'm going to hide this. Why did we use a negative remainder technique earlier? It's because it's a technique that you should know. It doesn't mean you're going to use that on every question. We might use that in question number 9. And guys, remember, you've learned a lot of stuff. You've not revised that stuff. So I understand some confusion over here, but let's get to question number 9 for people who are here. So still solving before question number 9. 80 people saying still solving before we go there. Three, two, and 1. Let me end the poll, or rather remove broadcast results. Here is question number 9. Take a stab at it, guys. All right, guys, close to 80% of you are done. Let's get those answers in. All right, 3, 2, and 1. Let me end the poll and broadcast the result. Okay, much better result than what we had last time. Let's just see the result that I think much better result. Let me just not jump the gun here. Let's see what was the result last time. Yes. Um, if I remember correctly, choice A was the correct answer. And now we have 47.7% of you choosing choice A which is great. If you look at pure numbers, despite having a third fewer participants, we have twice as many of you have chosen, have gotten to the correct answer. That's wonderful. That's improvement right then and there. Okay, so what's given to us? This is the last question we're going to solve today, and then we're going to really see where we want to go from here. Okay, so in this case, the first thing we're going to do is we're going to do simplification. We're going to really understand, process the question statement before we even go to statements 1 or 2. All right, let me clear a few things up at my end so I have a few fewer things to deal with. So what we are given is, let's analyze the question statement and simplify it. What we are given is, we've defined the remainder of this complex expression 38 to the power n square, and that number is divided by 13, where n is greater than 0 and is a positive integer. Okay, and we have to find out what's the remainder over there. Okay. Now, let's kind of simplify this. The first thing that you're going to use over here is you say, hey, it's 38, it's 13. I'm going to use what? I'm going to use the concept of? I'm going to use the concept of what? Let's negative remainders. Yes, I'm going to use the concept of negative remainders. Okay. So I'm going to use that concept of negative remainders. I'm going to express 38 as 13 times 3 minus 1. We don't want to use the positive remainders concept. So when I do that, I get my remainder as minus 1 to the power n square. Okay. When I do this, I have two options left. If n is odd, then my remainder, and one is when n is odd, the other is when n is even. When n is odd, my remainder is negative, it's minus 1, and I have to add 12 to it, or I have to add 13 to it to get my positive remainder, which is 12. If n is even, my minus 1 to the power, an even power is even, and I get plus 1. Okay. How many of you were able to do this level of simplification when you solve this question? How many of you will be able to were able to do this? Okay, I'd like to see a few more responses here. How many of you were able to do this? I want, and again, get a few more. Let's get a few more responses. Why? Because I have more responses on the poll. I have close to over 100 responses. I only have 78 responses here. Now, if you were able to do this, pat yourself on the back, because this was the core thing in this DS question. So pat yourself on the back. But if you were able to do this and you got the question wrong, slap yourself on the head, because despite doing this, you still made the mistake. Okay, this was the core thing. If you got this and still got the question wrong, it's not because you lacked the concept. It's because you made a mistake that you shouldn't have made. So the takeaway over here is we have to figure out what the hell is n, and because once we know what n is, we can answer with 100% certainty what my remainder is going to be. So let's analyze statement 1. Statement 1 says n leaves no remainder when divided by 4. Okay, so which means n is equal to 4 times something, which means 4 times anything is even. 4 times 3 is 12, 4 times 2 is 8. So 4 times anything is even. Statement 1 is sufficient. It tells me that my remainder is going to be plus 1. Okay. Now, so statement 1 is sufficient, which means it's either choice A or choice D. B, C, and E are out of picture. Then statement 2. Statement 2 says square root of n is only divisible by 1 in itself. So the only number that's divisible by 1 in itself is a prime number. So which it means is that square root of n is a prime number. All right. When square root of n is a prime number, then in that case, n becomes a square of a prime number. Now, what does that mean? It means n can be 2 square, n can be 3 square, n can be 5 square, or 7 square, which means that n can either be even. Why? Because 2 square is even, and 3 square is odd. So n can be either even or odd or odd. And because n could be either even or odd both, it doesn't give me one definitive answer. Okay, which means statement 2 is sufficient. Or statement 2 is not sufficient, I'm sorry, which means my correct answer is choice A. Vanessa says, when you know A can be an answer, why do you automatically cross out choice C? Vanessa, the key to it is knowing what choice C is. Choice C says both statements are required. Okay. If you know that statement 1 can get you to a definitive answer, then you know that both statements are not required. Does that help you, Vanessa? Okay. So that's how you can cross choice C. So where did you guys made a mistake despite doing all of that processing? Where did you make a mistake here? Can you solve any questions on remainders now? You should be able to solve most questions on remainders that are there. You tried determining n. Missed 2 as a prime. Okay, calculation mistake, even odd power. Okay. So I know we've not solved 10th question. I'm going to give the PDF to you. The solution does exist in the PDF, so you guys can do that over there. So for those of you who are intimidated by 32 to the power 32, you probably should really know no one's doing the math over there. That's not what we want to do. But let's see where we go from here. Why? Because we're already 10 minutes ahead of our schedule. These are not official questions. These are e-GMAT questions over here. Okay. So I want to first give you some evidence of how people have mastered GMAT quant, and I'm going to show some case studies over here. Here's a guy who was good in quant. He was someone who did well in quant always, and someone who actually felt he could just do GMAT quant, and he was able to get to that score of Q48, but beyond that struggled to improve. Why? Because the person was doing math and not GMAT quant. And one area where this person constantly faltered was data sufficiency. Okay, so I mean the piece over here is says similarly for equation based questions, I never knew that I could keep variables till the end rather than doing the math right away. When he changed his approach, he was able to improve to Q51. So if you're someone who's stuck at that Q48 where you know the concepts, you're able to do easy and medium questions, you're only faltering in a few kind of hard questions, which is pushing your score down. Just make sure you understand where you're faltering. Okay. Here's a guy who actually was what I call as in a hopeless situation and was able to get into Wharton. So Leonardo couldn't improve beyond Q45 despite spending a ton of time. He was able to get to Q49 and using very similar approach. One thing which he did in addition to doing this approach is that he used analytics. That was really there. Why? Because it allowed him to focus on which areas was he making mistake in. Okay. He got into Stern, Tepper, and Wharton. He actually is just graduating from Wharton. As a guy who was again at a Q30, a very low score, was able to improve to a Q45. For him, the key was not to solve difficult questions upfront. So in this webinar, we started with very easy questions. We just looked at the Euclidean equation and increase the difficulty level. And you can really see how as you go and focus and do practice in the right kind of sequence, take the learnings, put them back and apply them again and again, you can go from solving the easiest questions to solving some of the most challenging questions in a span of about 2 hours. Okay, so yeah. He was able to improve to a Q45 from a Q30, and he was able to improve even beyond that over there. And Guillermo, again a Wharton guy, improved from a Q38 to a Q50, again using a combination of these approaches. focused on learning. Someone's asking, hey, I've just bought the e-GMAT course. I've attended these 2 webinars, but I'm starting with verbal. What should I do? Follow that focus, that sequence of learning. Follow the study plan that's been provided to you, because that's personalized to your starting scores. In his case, the study plan that was given was personalized to his starting score. And you know, when you get to quant, you'll have these webinars again. We do these webinars very frequently overall. So, and in fact, we're going to be doing more and more webinars for our paid students. So just stay tuned, wait for another 20 days or so, and you're going to be in for a big surprise. So, but again, for him, the idea was, you know, starting at a Q38, getting to a Q50, he had to build that foundation first, figure out where he needed to put in the effort, and then track his improvement. And I mean, imagine Wharton is a quant-focused school. At Q38, it was probably was not even on his radar. Once he got to a Q50, he was able to really apply and get into Wharton. Okay. So again, if you want to ace GMAT quant, follow a process, build those process skills, and don't just blindly solve questions. Solve questions in a logical sequence, and solve questions using the right method so that you don't do the math. Okay. Again, some things over here that I want to have you take away from this. The first thing is, you know the concepts, but beyond that, be methodical. Don't be scared of the question statement. Why? Because you're not going to have to do the math over there. You've got to trust the test maker in that case. And then as you build your skills, believe in them. Perfect those skills before you move forward. Why? Because if you don't perfect those skills, if you leave gaps, then you're going to find that those gaps come and haunt you later. All right, with that, as next steps, make sure you review the concepts in the free trial. If you're studying quant, we have added a couple of new concepts in the free trial. If you have the paid course, you already have everything that you need. Solve the practice questions in the PDF that I'm going to share just now. Also in Scholaranium if you're a free trial student. And again, if you like what you see, consider the paid course. Here is the session PDF. Okay, can GMAT online be with that? I'd like to get some feedback on the webinar. If I can get some feedback, that'd be great. Over here. I have a bunch of questions that I have about the GMAT online test, but again, let's see the feedback on the webinar, also the learnings and takeaways. If you could type those answers in over here on the right hand pane, that'd be really good. What were your takeaways from this webinar? The 10th question is there in the PDF, guys. Now, all right. You can have the recording too. Absolutely, yes. Absolutely, you can have that recording, and we'll send you the recording over. So let me answer those questions about GMAT Online. Just give me 1 second. First of all your questions about GMAT Online are probably answered in this webinar over here. Let me copy this. And this is a webinar that we hosted with the GMAC that you can really get to. Okay. Would you prefer going for the GMAT online exam? I do. If you have a stable enough internet connection, Aditi, I would prefer that you go for it. Again, when you watch this recording, we kind of evaluate who should go for the GMAT online exam and who should not. Hugo, as of now, the GMAT online exams can only be taken once, but I'm very certain that the GMAT's working on making sure that you guys can take it multiple times. Now, if you took the exam or if you attempted the exam before 11th of June, you can take it once more over there. All right. So, any other question? That's there. If there's no other question, then I'd like to thank you guys for joining me today. It was wonderful having you here. And once again, subscribe to our YouTube channel, connect with me on my LinkedIn. I have about 15,000 students who are connected with me on my LinkedIn. So if you want to connect with people in top business schools, that's an excellent way of doing the same. Also, make sure uh, that you register for the upcoming webinars. Here are the upcoming webinars. The RC webinar as well as the quant workshop. You can do that. And I want to thank you guys for that lovely feedback. It really boosts our confidence. It motivates us to do better. It motivates us to do more sessions overall. So thank you for taking the time to be with me today and be with my team, Vipul and Harsha, who are supporting me in this webinar. I'm sure they're delighted as well. And we look forward to having you on e-GMAT.com. And go get your target GMAT score.